Let's look at the solutions to episode 10 puzzles now. Prime puzzles. Let's get at it. In a city, there are three types of buses: ordinary, metro, and luxury, available for local transportation. The price of the ticket for each bus is fixed up to a distance of 4 kilometers. And that fixed price is rupees 20, rupees 30, rupees 60 for ordinary, metro, and luxury buses, respectively. If a passenger needs to travel for a distance more than 4 kilometers, an additional fare will be charged at the rate of 20 per kilometer, or 10 per kilometer, 8 per kilometer for luxury, metro, and ordinary buses. Okay, pay attention. The question has gone ahead and changed the order. First is was ordinary metro and first it was ordinary metro and luxury. Now it is luxury, metro, and ordinary. So 10 and 30 are grouped, and 8 and 20 are grouped. Okay. Distance in kilometer traveled by any passenger need not be an integral value, but the additional fare will be charged for the entire kilometer, even if the passenger traveled additionally for less than 1 kilometer after traveling 4 kilometers. Okay, so if I've traveled 4.1, I have to pay the fee for 5 kilometers. This is what this additional instruction is telling me. Okay. Next is further, there is a facility of a monthly bus pass available for each of the three types of buses, enabling unlimited travel in a month. Prices for the bus pass of ordinary, metro, and luxury buses are 1,000, 2,200, and 6,300 respectively. Every passenger tries to minimize the total amount that he or she has to spend each month on bus travel, that is on tickets or bus pass, based on the distance traveled during the month and its cost. Okay. People are looking to minimize their expenses. Very, very natural thought. First question. Ritika always travels only by luxury bus. Okay. She used to travel 3 kilometers from home to office. So here she will pay 60 rupees because that is the minimum fixed price that she has to pay. 2 kilometers from office to gym. Again, she will pay 60 rupees. An X kilometer from gym to his office every day. Okay. Should not be his, should be her. Because Ritika, not that I'm saying the name gives away the gender, but in the latter part of the question, we are talking about minimize her expense. So here also it should be her. Makes most sense. Anyway, it doesn't really impact the quality of the question. Text from gym to her home every day. If Ritika bought the monthly bus pass every month in the year 2017 to minimize her expense on traveling, then which of the following must be true about X? Now pay attention, she bought it in every month of the year 2017. So even in the month in which there were few days or the fewest days, it was more beneficial for her to buy a bus pass. What this essentially means is her expenses, first she travels 60, pays 60, then 60. Then for the third travel, she pays 60 plus let's say all the options are greater than 4 only. So X minus 4 into how much? 20 per kilometer, no? 20 per kilometer. This much she has paid per day for 28 days. And this is still greater than the bus pass, which costs 6,300. Okay. So let me work with this. First thing I will get is within brackets 180 minus 80. So 20x plus 100 into 28 is greater than 6,300. So I can get rid of zeros. I can get rid of 14. This will be 45. So 2x plus 10 is greater than 22.5, or 2x is greater than 12.5, or x is greater than 6.25. And at this time, brilliant thing that you have to pay attention to, that if you've missed out, you will make a terrible, terrible error. Distance in kilometer traveled by any passenger need not be an integral value, but additional fare will be charged for the entire kilometer, even if the passenger traveled additionally for 1 kilometer after traveling 4 kilometers. So just the partial. So if it says 6.25, even if she was traveling 6.13, she has to pay for 7. Even if she was traveling 6.7, she has to pay for 6.7 kilometers. She has to pay for the entire 7 kilometers. So the answer here will not be option 3. Answer here will be option 4. X is greater than 6 kilometers. X is greater than 6 kilometers. The changeover point or the decision making point has to be an integral value. The changeover will only happen at integral places. It will never happen at decimal places. This much you need to know. Okay. Next question. Let me get rid of this working. Wow, one go itself. I'm happy. On each day of the month in June 2018, so 30 days, Reyansh traveled X kilometers from home to office by a metro bus and 3x by 2 kilometers from home to office via a different route in a luxury bus. If Reyansh purchased a monthly pass for only luxury bus and not for a metro bus, then how many integral values can X take? Okay. The good thing is all the options are precise, which means there has to be unique values to be considered here. So first thing I have to identify is whether X is less than equal to 4 or X is greater than 4, because calculation in these two situations changes. So let's say X was less than equal to 4. So 3 by 2X will be less than equal to 6. In this case, 3 by 2x will be less than equal to 6. Let's take the extreme amount. Even if the distance traveled every day by the luxury bus was 6 kilometers, how much will be the charges? 60 plus 2 into 20, 40 per day on luxury bus. These will be the charges, and there are 30 days in a month. So charges for the luxury bus used by him will be 3,000. In this case, he would definitely not be getting a pass. Pass costs 6,300 and his luxury bus charges are only 3,000 even when he was traveling 4 kilometers every day. Which tells me for certain X has to be greater than 4. X has to be greater than 4. Now, if X is greater than 4, under the metro bus working, he is paying 30 plus X minus 4 into 10 into 30. And this is this is less than the bus pass charges. Less than metro bus pass was 2,200. Okay. So at this time, I can get rid of a 0. I can get rid of another 0 from here. So X minus 4 plus 3. So X minus 1 is less than equal to 22 by 3, 7.33. Or X is less than equal to 8.33. One limit for X I have identified. This is for the metro bus journey. For the luxury bus journey, his charges would be 60 plus 3 by 2x minus 4 into 20, whole thing into 30. And now this has to be greater than 6,300. Okay. Let me get rid of this. I get 210 here. I can get rid of zeros more. All zeros are done. So 3 by 2x, so 3x minus 8 plus 6. So minus 2 is greater than 21, or x is greater than 7.66. I have found another limit for x. I already had one limit for x. So how many integral values can x take? Answer has to be 1. There is just one integral value that x can take. When x is equal to 8, only then does it make sense for him to buy a luxury bus pass, but not a metro pass. Moving on. Next question. If Jay always travels by the same type of bus and he travels n kilometers from home to office and n kilometers back from office to home every day, then how many of the following statements are definitely true? Okay. If n is less than equal to, n is less than 4.93 and he always travels by metro bus. Okay. So metro bus was 30 and 10. Then he will not buy a monthly pass for the month of February 2019. Okay, let me check. February 2019 is 28 days and he's making this journey 2 times. So one way his cost would be 30 plus x minus 4 into 10 has to be less than 2200. Yes, I think this is right. Okay. So first thing I'll do is get rid of these zeros. Then get rid of this 2, 110. Also get rid of one more 2. So 14 and 55. So I get x minus 4 plus 3. So x minus 1 is less than 3 whole 13 by 14. So x is less than 4 whole 13 by 14. But again, do you remember from the first question and insight that we had developed? The limits will never be in decimals. The limits will always be in integers. And therefore, the first statement is flawed. Although this is roughly 4.93. This is roughly 4.93. Can I say even if his distance was 4.5, he will buy a metro pass? Even if the distance that he had to travel from to and fro was 4.5 kilometers, he should buy a metro pass. So this is not true. Next, let's look at it. Which should also give me a trigger. I don't really need to check when the limits are given to me in decimals. But why I do need to check them, is only to ensure that the limit is actually less than equal to 4. Say after all the solving for the second statement, it turns out n is less than equal to 8.34. Then yes, not buying a monthly bus pass would be acceptable for this person. So I have to do the maths, but know that when they say 4.3, what they actually mean is less than equal to 4. When they say 4.26, what they mean is actually less than equal to 4. What they actually mean is less than equal to 4. Here also less than equal to 6. Let's look at ordinary bus working for May 2019. So it will be 31 days. 31 days. So let's go. So 31 into 2, ordinary bus charges are 20 plus 8 into x minus 4. This whole thing has to be less than 1000. Okay, so this turns to 5, this turns to 2, this turns to 250. This con turns to 125. Okay, so 125 by 31 gives me how much? 4 whole 1 by 31. And here I'm left with 2x minus 3. 2x minus 4. I'm just converting 31 into 2, 20 plus 8 into x minus 4. Yes, seems appropriate. First, I cancelled 4s. Then I cancelled a 2. 31 into 4 is 124. I can't get the maths of it. I need more space. Should not have done it on this side. I should have done it niche. I need more space. For an ordinary bus, the charges are going to be 20 plus 8 into x minus 4 for the entire month of May. So 2 into 31. He will not buy a monthly bus pass. Okay. So this has to be less than equal to 1000. Monthly bus pass for ordinary was 1000. Okay. So let me cancel it off by 4. So 250 and 2 and 5. 2x minus 8. So 2x minus 3. 2 gone, 125. 125 by 31 has to be less than 4 whole 1 by 31. It seems right. No problem so far. So 2x is less than equal to 7 whole 1 by 31, or x is less than 3 whole 3 point something something. Now see, x is less than 3 point something something. Even then he will buy a monthly pass. Even then he should buy. Let's say x was equal to this, whatever value we get, 7 whole 1 by 62, or sorry, 3 whole something by 62. Even then he should buy a monthly pass. This is what we are getting. So even when his distance is less than 4.26, he always travels by ordinary bus. He will not buy a monthly bus pass. This is a flawed statement. This is not valid. He will buy a monthly pass if he has his distance as 4.2. He should buy a monthly pass. If his distance was 4.1, he should buy a monthly pass. Second statement is also flawed. Okay. Let us look at the last statement now. Ooh, luxury bus. So 2 into February 2020. This is a divisible by 4. So 2 into 29 into 60 plus 20 into x minus 4. And finally, should be less than 6,300. Okay. I can cancel this. I can cancel this 3 times. If I cancel this by 20, I get 315. Okay. So x minus 1 is less than 315 by 58. 58, or x is less than 58 if I add to this. 373 by 58, which should mean how much? 5 point something. 5 am I crossing? 58 into 5 is 290. Yes. Into 6 am I crossing? 6 point something, no, is less than 6 point something. I don't really care for it, what the precise number is. Can I say this is flawed now? This is flawed now. I can get the precise value. So 290 plus 58, 348, 348. So this is 6 whole 25 by 58. Most likely it is going to be 6.43 only. But even if I get x is less than 6 whole 25 by 58 or 6.43, even if it is 6.3, he will buy a bus pass. Even if it is 6.2, he will buy a bus pass. So this statement is also not true. So none of the statements are true. Answer is option 1. What a waste of a question. You do all this work to get to none of the statements are valid. Last question. 3 friends, Ravi, Jay, and Govind, travel every day for once by ordinary bus, metro bus, and luxury bus, respectively. So Ravi with ordinary bus, Jay with metro bus, and Govind with luxury bus. None of them bought a monthly pass for May. If R, J, and G represents the maximum distance that they could have traveled by each of them in a day, then which of the following is true? Okay, so maximum limit that they can travel every day so that they don't have to buy a monthly pass. Seems like a fairly simple work. Let's see. For Ravi, his charges are how much? 20 plus 8 into x minus, okay, this is May, so 31 I have to take care of, x minus 4. This whole thing into 31 has to be less than 1000. Let me budget space because I will need the working for subsequent places. So this will be 250. This will be 2. This will be 5. So I get 2x minus 3 is less than 250 by 31. Okay. So 2x is less than 31 into 3 is 93. So 343 by 31. So 2x is less than roughly 11 point something something, or x is less than 5 point something something. So I know the upper limit r can travel. The upper limit r can travel is 5. Anything beyond 5, we'll have to pay more. So 5 is the upper limit that r can travel. Let us look at j. His cost would be 30 plus 10 times of x minus 4. This whole thing into 31 is less than 2200. So I can get rid of zeros. So this gives me x minus 1 is less than 220 by 31. So 31 into 7 would be 217. Okay. 7 whole 3 by 31. Cool. So x is less than 8 whole 3 by 31, or the maximum limit x can hit is x is j, no? J will be 8. So I know r is smaller than j. This option is gone. This option is gone. Between these two, I'm still left. A1 and 2 can still work. So I have to do the work for the last one. So 60 plus 20 x minus how much? 4. This whole thing into 31 is less than 6300. Okay, so this is 3, this is 1, this is 315. So I've got x minus 1 is less than equal to n whole 5 by 31, or x is less than 11 whole 5 by 31, or finally the max value g. This can go up till 11. So g is the largest. So option 2 will be correct. This is the entirety of the set. Requires a lot of processing, maths and everything, but it is fun. It can be done. And I think I got lost in checking these statements, which ended up taking a lot of time. Anyway, moving on. Next set. This is a set from CAT 2006. A significant amount of traffic flows from point S to point T in one-way street network shown below. Point A, B, C, D are junctions in the network, and the arrows mark the direction of traffic flow. If the fuel cost in rupees for traveling along a street is indicated by the number adjacent to the arrow representing the street, okay, the fuel cost, I read if. So the fuel cost in rupees for traveling along street is indicated by number of adjacent arrow representing blah and blah. Motorists traveling from point S to point T would obviously take the route for which the total cost of traveling is the minimum. Makes sense? If two or more routes have the same least travel cost, if two or more routes have the same least travel cost, the motorists are indifferent between them. Hence, the traffic gets evenly distributed among all the least cost routes. Okay, so we are looking at motorists who are traveling from S to T. What all routes are available to them? Let's go SAT, SBAT, SBCT, SDT, and SDCT. These are the 5 routes using which motorists can travel from S to T. And we also have our basic cost, fuel costs involved. So 14, SBAT is 9, SBCT is 7. SBCT looks like the best route as of now. SDT has 13 and SDCT has 10. Okay, these are the fuel costs along these routes known already. The government can control the flow of traffic only by levying the appropriate toll at each junction. For example, if a motorist takes the route SAT using junction A alone, the total cost of travel would be rupees 14, rupees 9 plus 5, yes, plus the toll charged at junction A. Okay, so if somebody is traveling this path, this way, whatever is the toll charges for A, that will also get incorporated. Fine. Let us get to individual questions. If the government wants to ensure that the traffic at S gets evenly distributed along the streets from S to A, S to B, and S to D, S to A, S to B, and S to D, then a feasible set of toll charged in rupees at junctions A, B, C, D respectively to achieve this goal is. Now see, the best way to proceed in this question is to check options, Nothing else is better. If you try to come up with some formulation, if you try to come up with some beautiful way of solving, you are most likely going to get stuck rather than solving it. So let's start checking option 1. This is the charge for A, this is the charge for B, this is the charge for C, this is the charge for D. So SAT, this will continue to remain 14. SBAT, 5 has increased, so this will also become 14. SBCT, so 9 has increased, so this will become 16. SDT, this will become 14. And last SDCT, 5 more. This will become 15. Now see, which are the least cost routes? S, this, and this. These 3 routes are the least cost routes. Traffic from S to A, S to B, and S to D. Yes, equally traffic will get distributed because our objective was to ensure that traffic distribution from S to A, S to B, and S to D is equally distributed because these are the 3 lowest cost routes. Of course, that objective will be achieved. So 1 seems likely. For peace of mind, you can also go ahead and check other options. I will do that right now. This was option 1. Let us look at option 2, 0522. So this remains 14. This becomes 14. Now SBCT, this also becomes 14. Cool. Now what happens on SDT? Only 15. Okay. And last is 4 more. This also becomes 14. Now see, this route will be eliminated. These 4 routes will be taken. These 4 routes will be taken. If these 4 routes are taken, can you see S to A, S to B twice, and S to D once? Can I say the distribution will be 25% here, 25% here, 25% on this route, and 25% on this route? So traffic moving from S to B is going to be 50%. It is not going to be equally distributed, S to A, S to B, and S to D. So this is flawed. This should not be there. Option 2 is incorrect. Let us also do the work for option 3 and option 4. That is all the work this question actually needs. So 1, so this becomes 15, 5 and 1. So this becomes 15 as well. 5 and 3, 8. So this becomes 15 as well. 3. So this becomes 13. 6. So this becomes 16. So now see, nobody will go through the route everyone will go through the route SDT. Sorry, 13 was present here and 3 more. So sorry, 16. Sorry. This will be 16. So everybody will, now people will go via SA, SB, and SB. Nobody will go via SD at all because that is the expensive route. So this is also not correct. Let us check option 4. 1. So this becomes 15. 1 and 5. So this becomes 15. SBCT. So 8 more. This becomes 15. SDT. 13 plus 2. This becomes 15. And finally, 10. 3 and 2. This also becomes 15. It may seem like it is wonderful. It may seem like it is wonderful, but see, now when the split happens, 20% of the traffic goes here, 20% goes here, 20% goes here, 20% goes here, and 20% goes here. Can you see S to B is happening 40% for 40% of the traffic, and S to D is happening for the 40% of the traffic, but S to A is happening only for 20% of traffic. So this is also not acceptable. The only acceptable choice is the first one. We were lucky that it was the first one. Let's hope we maintain our luck in the subsequent questions as well. Let me get rid of all this writing down. Moving on to the second question. If the government wants to ensure that no traffic flows on the street from D to T, okay, so D to T, so this route is out of question anyway, while equal amount of traffic flows through junctions A and C, then feasible set of toll charges in rupees at junction A, B, C, D represent. Now see, basically, if we want equal amount of traffic flowing through junctions A and C, A is mentioned in this route, A is mentioned in this route, and C is mentioned in this route, and C is mentioned in this route. We want a 50% split across these four. We want equal charges across these four. So let us look at the options all over again. 1, this becomes 15. 1 and 5, 6 more. This also becomes 15. SBCT 8 more. This also becomes 15. And SDCT 6 more. This becomes 16. And therefore, this is an unacceptable choice. Can you see? The traffic will get distributed here at these three spots, and SA will have 66% of the traffic passing through it, and toll A will have 66.66% of the traffic passing through it, and toll C will only have 33.33% of the traffic passing through it. So this doesn't work. Let us go to option 2, 0522. So 14, BCT, 7 more. 14 seems promising. Last one, 12. Sorry, not 12. Also 14. Also 14. This seems nice. This seems amazingly nice. Why this seems amazingly nice is, see, now 25% of the traffic, 25% of the traffic, 25% of the traffic, 25% of the traffic. Yes, traffic flowing through A will be 50%, traffic flowing through C will also be 50%. So as of now, this seems like the answer. For peace of mind, I will also check option 3 and option 4. Let us go. Option 3 gives me 15. This is also 15. Next is SBCT, 9 more. This gives me 16. And last is 6 more. This is also 16. All the traffic will flow through it. This is not ideal. Let us look at option 4. 05. So 14 and 14. Then 7 more. So 14. Last is 5 more. So 15. Again, this is not good. This is not good. This is as good as option 1 itself. 66% of the traffic will flow through A. 33.33% of the traffic will flow through C. This is not ideal. So this is also gone. Answer has to be option 2. Next bunch of questions, same storyline. So let me write down SAT, SBAT, SBCT, SDT, and SDCT. What were the base charges? 14, 9, 7, 13, 10. 14, 9, 7, 13, and 10. These are the fuel costs. These are there. Let's look at the next question. If the government wants to ensure that all motorists traveling from S to T pay the same amount, fuel costs and tolls combined, regardless of the route they choose to choose, and the street from B to C is under repairs, hence unusable. So if B to C is under repairs, this route is not available anymore. Then a feasible set of toll charged in rupees at junction ABCD respectively to achieve this goal is. Now we have to again do this. Let us look at option 1. Let me use a different pen. Option 1, 2532. So 2, this is also 16. Next is SBCT is not present. So SDT, 2 more, 15. Nope. This I have different rates coming. So this option is wrong. Gone. Option 2, I have 0. So this is 14. Cool. 5 also 14. Third is SDT. So 2 more, 15. Okay. This is also wrong. Doesn't work because SDT and SAT are not paying, are not giving the same charges. Let us look at option 3. So this is 15. This is also 15. 2 more. So this is also 15. Finally, 5 more. So this is also 15. Seems like the right one, because in regardless of what route you take, SAT, SBAT, SDT, or SDCT, you're always getting the same charges. Let us look at the last option, option 4. Peace of mind is extremely important. So 16, 235. So 14 gone. First two are not giving me the same charges. So answer has to be option 3. Let me get rid of everything then. Next question now. Okay. If the government wants to ensure that all the routes from S to T get the same amount of traffic, then a feasible set of toll charges at junctions A, B, C, D respectively to achieve the goal is. Okay. So it is basically the same question as the last one, just that BC is also in play now. BC is also in play. SBCT route is also in play. Okay, let us look at options. I'm inclined to check option 4 first. It is the same as that. I know 4 get same. B, C, 8 more. I get 15. So I know option 4 is the answer, but we will do it the right way. We will go from every option from the beginning. Let's go first one. Option 1 gives me 14. 14. SBCT 71. 14. SGT 15. No, the prices have changed. So this option is wrong. Now 0541. 0541. Let's look at it. So 14. 14. 9 more. This is 16. No, this is not valid. Let us cancel. 1533. So 15. 15. Next is 5, 3 more. So 15. Then you have 16. No, prices are different, not valid. Last one, 1542. 15. 15. 5, 3, 8 more. So 15. SDT, just 2 more. So 15. DC, 5 more. 15. Yes, charges are identical across whichever route you take if the toll charges are option 4. Last question now. The government wants to devise a toll policy such that the total cost of the commuters per trip is minimized. Okay, the government wants to minimize the expenses for the commuters. The policy should also ensure that not more than 70% of the total traffic passes through junction B. Okay. The cost incurred by the commuter traveling from point S to point T under this policy will be. The options available are 7, 9, 10, 13. Okay. Now see, this is the lowest price here. This is the lowest price here. If no tolls were levied, if no tolls were implemented, in 7 rupees, a person can go from S to T, which is wonderful. But if tolls were indeed levied, or even if tolls were not levied, the problem would be everybody would go to SBCT. Everybody would go to SBCT. That is not ideal because we have to ensure that not more than 70% of the total traffic passes through junction B. So we can't have SBCT alone. We can't have SBCT alone. So my tolls will be implemented somewhere. 7 cannot be the answer. The next best case is rupees 9. Basically, I have to come up with a way in which these two routes become comparable or identical. So if I levied a toll of 2 rupees at C, if I levied a toll of 2 rupees at C, can you see this will also become 9, this will also become 9, and it would be awesome. Except the fact that the policy should also ensure that not more than 70% of the total traffic passes through junction B. But right now, again, 100% of the traffic is passing through junction B. This is also not possible. Can't really have this. Let us look at 10. 10 is interesting because here, if this is 7 and if this is 10, if this is 7 and if this is 10, and B is only present here. Let's say I implemented a toll of 3 rupees here. I implemented a toll of 3 rupees here. This will go up till 10, a toll of 0 rupees here and a toll of 0 rupees here. This will also be 10. So people can take the two routes and only 50% of the population will go here. 50% of the population will go via this route. So now at the third lowest option, I am able to ensure that the traffic passing through B is lower than 70%. And therefore, this is the answer. I don't need to check any further. 10 will be the answer. This is one of the more wonderful sets from an era where you had lots of time and lots of wonderful sets being presented to you. I hope you learned something from this episode. Okay, bye.